transformations in the coordinate plane, which basically means transformations on graph paper. So on our first one, we're going to translate this polygon right 3 and down 2. It's a translation. So we're basically taking each point, A, B, C, and D, and moving them right 3 and down 2. So if I take point A and move it right 3 and down 2, it goes to here, and I'll call that point A prime. Now, I don't have to draw in those little dots to show that. I'm just helping you count. So point B, move it right 3 and down 2. Label it B prime. Move it right 3 and down 2. Label it C, image as C prime. Go to D, right 3 down 2. Call it D prime. And then all we need to do is to connect those 4 points. And we get figure A prime, B prime, C prime, D prime. And it looks like you just moved that entire figure right 3 and down 2. So translations are pretty straightforward. Reflections and rotations, we could express them with a bunch of rules, and what I'd actually like you to do is to take a minute and maybe copy these rules down. I'll let you pause the video so you can see what's going on there. What I will tell you is that with these rules, you don't have to use the rules, and I will show you how the rules are not used as well as how we could use them. So do me a favor, pause the video here, copy down these rules, and then come back when you're done. All right, well, let's take a look at how we do those rules. So if you look at our next one, we have triangle PQR. Let's graph triangle PQR. Triangle PQR has a vertex at P, which is at 7, 6. Here's point P. Q is at 2, 8. And R is going to be at 4, 3. So here's my triangle PQR. Take a minute, graph that triangle. And then we're going to graph its image, P double prime, Q double prime, R double prime, which is the image after a reflection over the x-axis, and then that's followed by a reflection over y equals negative x. That's kind of why we have this as a double prime triangle, because there's going to actually be 2 images going on here. So let's see if we can do them, and we'll do the rules first. So the first one is a reflection over the line y equals x. Oh, I'm sorry, reflection over the x-axis. So my point P, or let's do this first. Remember the rule for reflecting over the x-axis was that each point x, y, the x value stays the same, but the y becomes negated. So it goes to x negative y. So let's take a look at what this is going to be. Point P, we know, has coordinates at 7, 6. So then its image, P prime, the x value stays the same, but the y value changes. So we're going to go to 7, negative 6. And I'll graph the image in green. So now we're going to go over 7, we're going to go down 6. Here's where P prime is. Let's do the same with point Q. Q is at the point 2, 8. So Q prime, the x value stays the same, but the y value changes. It goes to negative 8. So if we're going to graph this, let's go to 2, negative 8. Here's point Q prime. Last one is point R. Point R is at 4, 3. So then its image, R prime, is going to go to 4, negative 3. Over 4, down 3. And what I'm hoping you can see is that it looks like my blue triangle was flipped over the x-axis to get to the green triangle. Now, we're going to follow this up with a reflection over y equals x. And remember, the line y equals x, if you were to graph y equals x, it has a slope of 1, a y-intercept of 0. So it's that diagonal line. So when I'm looking at this green triangle that I'm going to now reflect over the line y equals x, it's going to end up somewhere up here, because it's going to be reflected over the line that kind of looks like that one there. So let's see if we can figure out those points. And again, we're going to use our rule to do this. So I'm going to take these points over here, the image points. Maybe we'll do this one in purple. So the rule for reflecting over the line y equals x is that the x and the y value change their spots. So the x becomes the y and the y becomes the x. You switch the coordinates. So that means that point P prime, 7, -6, is going to go to P double prime, -6, 7. So let's go graph -6, 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Here's P double prime. Q double prime was, or Q prime, excuse me, was 2, -8. When we do our rule, we're going to get -8, 2. So let's go over -8. Let's go up 2. That's going to be Q prime. R prime right now is 4, -3. When we graph over line or reflect over y equals x, we switch the coordinates. So we'll get -3, 4. And if you take a look at that relationship now between our green triangle to our purple triangle, hopefully you can see that it looks like it was a flip over that line there. If we fold it over that line, it goes up into that area up above. So that's using the rules. And I'll be honest with you, in this case, I'm not a rule follower. So let's keep going to talk about how you might not use the rules. So in this case, we have triangle ABC. We're going to graph its double image after reflection over the y-axis, followed by a 90-degree counterclockwise rotation centered at the origin. All right, let's start. Let's graph triangle ABC. Point A is at 4, 1. Here's A. B is at 2, 6. Here's point B. And C is at 8, 7. So take a moment, graph that triangle. All right. So let's talk first about how to do a reflection over the y-axis. Remember that the line of reflection, in this case the y-axis, is the perpendicular bisector between a point and its image. So here's what that means. It means that, see how point A is 4 units to the right of the y-axis? Its image then will be 4 units to the left of the y-axis, because that y-axis is the perpendicular bisector of the segment A to A prime. So that line, the y-axis, has to be the same distance from B and B's image. So here's B prime. And it's the same distance from C as C's image. So C prime is going to be up here. So that green triangle represents the blue triangle reflected over the y-axis. I didn't do the rule, I just knew that the y-axis had to be the same distance from each one. Okay, so now let's handle the rotation of 90 degrees in a counterclockwise direction centered at the origin. I'm just setting up my grid to show you something. So this is like my favorite one to do. So what I'm actually going to ask you to do is to turn your paper 90 degrees counterclockwise. There we go. So now maybe your paper looks like this. So do you see where the green triangle is now? What I'm going to do is I'm going to pretend that now this is the positive x-axis and up there is the positive y-axis. I'm going to pretend that my graph is straight up. And then I'm just going to write down what the coordinates of my green triangle are now. So A double prime is going to be where my A prime is. Right now, that looks like it's at -1 for X, -4 for Y. I go the left 1 and then I go down 4. So now the green coordinate of A prime, which is now my new A double prime, is -1, -4. I'm going to do the same thing for B double prime. It looks like that's at -6, -2. I'm pretending now that my graph is straight, is like the normal way, it's not turned. And so C double prime is going to be at -7, -8. So once I do that, what I then do is I go back and I turn my paper back to normal. I put it back the way it should be, and I graph those 3 points. Let's graph -1, -4. A double prime. Let's graph -6, -2. B double prime. Let's graph -7, -8. C double prime. And what I'm hoping you see is that when you do that rotation, and I think I can do this, watch this now. I'm going to rotate my paper again. Now the purple triangle isn't attached to the grid. So when I rotate it, looky, 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 that's going to match up right on it. So I know my transformation was correct. So that's how I do these without using my rules. And I'll be honest with you, I don't do the rules. I find the rules are too many to remember. I like to do my reflections as the same distance from the line, and my rotations, I turn the paper. Okay, we're going to do a couple extra ones as well. So if you're following along, we're going to find the coordinates of point A after 3 different things, and we're going to do each one individually. So I'm going to graph it and then erase it, and then graph it, then erase it. So let's first start with where point A is. Point A is at -2, 5. Here we go. And the first thing I'm going to do is a reflection over the line y = 2. Okay, that's a line that I'm hoping you remember is a horizontal line that goes through where y is equal to 2. So this is the line y = 2. So I think the hard part of this is knowing where that line is. Because now you want to do the reflection. Remember, a reflection is how far you are away from the line. I'm 3 boxes above the line. Let's go 3 boxes below the line. Here's the image of A prime. The image of point A after reflection of y = 2. In this case, A prime is going to be at -2, -1. Likewise, say you want to do a reflection over the line x = 3. Well, if you go to where x is equal to 3 and draw a line through that point, you've got the line x = 3. Again, reflections are how far you are away from that line. 1, 2, 3, 4, 5. So let's go 2, 3, 4, 5 away from it on the other side. This is the A prime when you reflect over x = 3. It looks like that point is at 8, 5. Ugly looking 5, I apologize. The 0.85 is there. All right, we're going to have fun with this one. Check this one out. This is going to be a rotation of 180 degrees centered at the point 2, -1. So let me graph my center point here. The center point's at 2, -1. And maybe I'll call it C for center. Or no, maybe I'll call it M for center. Or M for Mahoney. Or M for math. Or M for, well, maybe you'll see. So if you think about what's going on here, there's like a circle. I have a circle tool. Watch this. There's this, basically, when you rotate something 180 degrees, it goes around the circle. So if you're looking for the image of this point after a rotation of 180 degrees, you're going halfway around the circle. So you're going not to there, but to the opposite side of the diameter. So maybe I should have called that point C for center, because it is the center of our circle. Or maybe it's M because it's a midpoint. Oh my goodness, it's a midpoint. Yeah. So watch what I'm going to do now. What I'm going to do here is I'm going to say, well, how far do I go from A to that middle point? 1, 2, 3, 4, 5, down 6. 1, 2, 3, right 4. Do the same thing. Down 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Go to the right 4. There's the image of A prime. It looks like this point is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. So it looks like this image is at 6, -7. And this 180 rotation also has another name that it goes by. We can say that a 180 rotation is also equal to what's called a point reflection. Sounds kind of weird that you reflect over a point. It doesn't kind of make sense. But the idea is that you're kind of just like reflecting straight through that, and it's the same distance in the same direction on the other side. So if I use point reflection, I'm meaning 180 rotation. Okay, one last one for the day. This is a cool one too. We're going to graph this triangle ABC. -2, 1 is where A is. 1, 4 is where B is. 3, -2 is where C is. Imagine this. Imagine if we can grab the sides of the graph paper and pull it apart, stretch it left and right. We're doing what's called a horizontal stretch. And this horizontal stretch is going to have a scale factor of 3 with respect to the y-axis. Here's what all that means. What it means is it's going to multiply the distance from the y-axis by 3. That's what our image is going to look like. Let's check it out. So right now, point A is 2 units from the y-axis. Multiply that by 3. Here's where A prime is going to be. B is 1 unit from the y-axis. Multiplied by 3. Here's B prime. C is 3 units from the y-axis. Multiplied by 3. Here's where C prime is. It looks like that blue triangle is what that purple triangle is when it's all stretched out. All right, friends. Hopefully this was helpful. Try some of that practice work now.